Let's solve 4 questions on how to find rightmost non-zero digit of any large power in just few seconds. First, 20 raised to the power 2024. Whenever you have 0 at the end of the base, ignore it. Only focus on the rightmost non-zero digit of the base. In this case, it's 2. So now you need to find last digit of 2 raised to the power 2024. Remember one thing, last digit of any number repeat in cycles. Carefully examine values of power of 2. 2 raised to the power 1 ends in 2. 2 raised to the power 5 also ends in 2. Similarly, 2 square ends in 4. 2 to the power 6 ends in 4. Clearly, after every 4 number, the cycle repeats. In this case, the cycle length is 4. From here, how do we know for power 2024? For that, simply divide 2024 by the cycle length, that is 4, and note the remainder. The remainder when any number is divided by 4 can be 0, 1, 2, 3. If you get remainder 1, look at the first term in the cycle. So that power will end in 2. If you get remainder 2, look for second term in the cycle. That power will end in 4. If you get remainder 3, third term is 8. Most importantly, if remainder is 0, look at the last term in the cycle. So the last digit would be 6. In this case, when 2024 is divided by 4, remainder is 0. That means you need to look for the last number in the cycle. So the last digit here would be 6, and the rightmost non-zero digit of 20 raised to the power 2024 will be 6. Let's practice a few more examples so that you never forget this idea. Second, 74 raised to the power 75. Here, rightmost non-zero digit of base is 4. Look at values of power of 4. 4 to the power 1 ends in 4. 4 cube also ends in 4. So the pattern is repeating after every second term, making cycle length 2. For divisor 2, remainder can be 0 or 1. If remainder was 1, we will look into first term in cycle, 4 raised to the power 1. So the term will end in 4. If remainder was 0, we look at the last term of the cycle, 4 square, so the last digit would be 6. In this question, if you divide 75 by 2, remainder is 1, which means rightmost non-zero digit of 74 raised to the power 75 is 4. Moving on to the third question, 125 raised to the power 100. The rightmost non-zero digit of base is 5. Let's look at powers of 5. This is a very peculiar case. Every term ends in 5. So here cycle length would be 1, and the remainder when any number is divided by 1 is 0. So here the last term of the cycle, which has only one term, will clearly end in 5. As you must have noticed, all these numbers have different cycle length. But you don't need to remember cycle length or the last digit of each term. Whenever you have any base, write the values of their power from 1 to 4, because the maximum cycle length of any digit can be 4. Let's end this discussion with the last example, 430 raised to the power 43. The rightmost non-zero digit of base is 3. Let's look at its values. Here cycle length is 4, and 43 divided by 4 leaves the remainder 3. Going to the third term in the cycle, the digit ends in 7, which is also the rightmost non-zero digit. If you learned something new today, write understood in the comment section.